This is section 7.1a, Linear and Nonlinear Systems of Equations. There are three ways to solve systems. Now some of these, or probably all of them, you've learned in Algebra 1 or 2. But in this chapter we're going to go into a little more detail, especially later on in the chapter. So the first method is substitution, the second method is graphing, and the third is elimination. Today we're going to talk about substitution. So the method of substitution is as follows. First, you solve one of the equations for one variable in terms of the other. So y in terms of x, or x in terms of y. Then, step 2 is to substitute the expression found in step 1 into the other equation to obtain an equation in one variable. Step 3, solve the equation obtained in step 2. Step 4, back substitute the value obtained in step 3 into the expression obtained in step 1 to find the value of the other variable. And 5, check that the solution satisfies each of the original equations. Now, this is a review. I know that you already learned substitution. You don't necessarily have to write all of this down step by step, but everything should become clear in the next few examples. So let's look at linear systems first. This is a typical and simple linear system. 2x plus y equals 5. 3x minus 2y equals 4. So all the system of equations is two or more equations. That's a system. And this system can be satisfied by a value of x and a value of y. So the method of substitution is what we're going to use to solve this system. We're going to start with our equation in which one of the variables is by itself. And we can see in the first equation, 2x plus y equals 5, the y is by itself. So we're going to start with that. We solve for y in terms of x, and we get y equals 5 minus 2x. And then we substitute that into the other equation. So 3x minus 2y equals 4 now becomes, with substitution, 3x minus 2 times the quantity 5 minus 2x equals 4. When you do the multiplication and simplify, you end up with 7x equals 14. And then, obviously, divide both sides by 7, x equals 2. Now, here's where the back substitution step comes in. We're going to back substitute that x equals 2 into the equation y equals 5 minus 2x because we want to find the value of y. And we get y equals 1. So I've solved this system by substitution, and I have my x value 2, my y value 1, and therefore the ordered pair 2, 1 is the solution for this linear system. Here's a word problem that can be solved by substitution. $12,000 is invested in two funds. One pays 5% interest per year, the other 3%, not compounded. If $500 is the total interest earned per year, how much is invested in each fund? Alright, so the first step when you get a word problem is to translate the English into math, and specifically, in this case, you're going to translate these words into two different equations. So pause the video now and try to set up those two equations of the system. That's the important first step. And then resume the video when you have those equations. So one equation is x plus y equals 12,000. That just refers to the fact that the 12,000 is invested in two funds. All right, so those two funds have to add up to 12,000. That's pretty simple. The other equation is 0.05x plus 0.03y equals 500. Now we know that because the total interest per year is $500, and that's 5% on the x account and 3% on the y account. So this is our other equation in the system. All right, now this is a system that you can solve by substitution. And so for practice, you should pause the video, try to solve this on your own, and then resume when you have an answer. All right, so we start with our simpler equation, x plus y equals 12,000. It's easy to get either variable by itself. So we can get x by itself, x equals 12,000 minus y. Then we substitute that into the other equation. So 0.05x plus 0.03y equals 500. Now becomes 0.05 times the quantity 12,000 minus y plus 0.03y equals 500. And now we can solve for y. And we find that y equals 5,000. So we know that $5,000 is in the y account. Now we back substitute because we need to find x. And when we back substitute and put 5,000 in for y, I get x equals 7,000. So the solution of this system, which I solved by substitution, is the ordered pair $7,000, $5,000. And those are my two funds. Now we're going to talk about some nonlinear systems, and that just means systems in which one or more equations is not linear. For example, it could be quadratic, cubic, any other kind of equation. So here's an example of a nonlinear system. X squared plus 4x minus y equals 7. And 2x minus y equals -1. Well, the first equation of those two is not linear, the second is, but this would still be called a nonlinear system. Now, we're going to solve this nonlinear system by substitution. So we'll start with y equals 1 plus 2x, and that's because we go to the simpler equation to get one of the variables by itself. Now at this point, you should be able to solve the rest of this on your own. So pause the video, do it on your own, and then resume when you have your answer. Proceeding now with our substitution method. We found that y equals 1 plus 2x, so we're going to substitute that in for y in the first equation. X squared plus 4x minus y equals 7 now becomes x squared plus 4x minus quantity 1 plus 2x equals 7. And then I can just simply proceed as I would in Algebra 1. And I get x squared plus 2x minus 8 equals 0. And I can go further and find that x equals -4 or 2. I get that by factoring and then solving for x. And then I have to back substitute with each of these values. And I get two ordered pairs. So one ordered pair is -4, -7. That is a valid solution for this nonlinear system. The other ordered pair is 2, 5. And 2, 5 is also a valid solution to this nonlinear system. Now, it would be good for you to just simply pause the video now and check that by plugging in -4 and -7 into the equations and see if that works. And then you could also plug 2 and 5 into the equation, see if that works, just to check the solutions. But anyway, the technique we used to solve this nonlinear system was simply substitution. And so you should have been able to do it on your own. If you have questions, you can ask in class. All right, now pause the video, check your solutions, and then resume when you have checked them. Here's another nonlinear system. X squared plus y equals 3, -x plus y equals 4. So use substitution to solve this system. Pause the video, do it on your own, and then resume when you have an answer. So you should have started with the simpler equation, y equals 4 plus x. Then you plug that y in to the first equation, so you have x squared plus 4 plus x equals 3. But then, when you get 0 on one side and you try to factor, you realize that you can't factor. And even if you use the quadratic equation, you're not going to get real solutions. You might get imaginary solutions. So the answer to this problem is no real solution. And of course, that could happen in a classwork problem. So just be ready. No real solution. Here's the classwork, page 504. Write these numbers down. You should solve all of these by substitution. Please do not solve them graphically. We're going to solve graphically in the next lesson. So solve all by substitution. Do not solve graphically.